On May 29, 2015, Soaring Eagle Zipline at Rushmore Cave in Keystone, South Dakota was operating normally. The ride was loaded with one rider, and the operator verified that both the seatbelts were securely fastened, one into the block behind the seat and the other into the standard seatbelt receiver. The operator then opened the start gate and dispatched the ride. When the ride reached the end of the course and decelerated, the rider was flung from their seat, falling 15 feet to the ground and sustaining injuries. The ride would be closed indefinitely as officials at the park worked to determine what had caused the accident. Rijko's engineering group would be called out to the park to help investigate. They would produce a report that examined several factors, including the ride's design, photos from the accident, and human factors. The full report would be released in August 2015 and serves as the base for this video. As per usual, the full report is in the video description if you'd like to read it. The ride had been manufactured by Soaring Eagle, which was founded by Stan Checketts and was one of the first Soaring Eagle ziplines to be built when it opened in 2011. The ride is a combination of a roller coaster and a zipline. It featured a single cable that the ride vehicle rode on top of, much like a regular zipline, with a drive cable located above this. The drive cable attached to the ride unit and looped back through a pulley system at the top and bottom of the ride. This drive cable is controlled by a single electric motor located at the top of the ride inside of the start hut. The ride started at the top of a hill and would mostly coast down the angled cable before being slowed by the drive cable and an air brake near the bottom of the ride. Originally, the ride slowed with only the use of the drive cable, but for unknown reasons prior to the accident, the air brake was added. The air brake worked by use of a catch placed in the path of the ride vehicle that is connected to a closed cylinder with air inside and a small escape hole. When force is applied, the air is compressed and slowly released through the escape, resulting in the ride's speed being controlled. This is a similar system to other rides produced by Stan's former company, S&S. The air brake would result in the most extreme forces found on the ride and would push riders forward, with riders feeling at least 1.7 G. After stopping, the drive cable motor would turn on and haul the ride vehicle back to the start shed. The ride vehicle itself featured two seats, both having their own non-retractable set of seatbelts, with one belt inserting into a monitored pin restraint and one inserting into a standard unmonitored receiver like what could be found on a car. The ride's control system monitored the active state of the pin restraint with two proximity sensors, one that monitored the position of the pin and another that monitored the position of the latch within the restraint block. If you have seen my video on Haunted Mine Drop, this is the exact same design of restraint. On this ride, the restraint's receivers are mounted behind the rider's seats on the ride unit's frame. This would require the operator to look behind a rider's seats in order to properly secure their restraints. The ride featured a device known as a ride key. This was used to unlock the monitored pin restraint on the ride unit, and when not in use, the ride key was stored on the control panel and the ride could not be started unless this ride key was in place. The ride featured a simple PLC-based control system that monitored the speed and position of the drive cable using encoders, monitored the active state of the pins and lock in the restraint block, and checked for the opened or closed state of the gate at the front of the start shed. This gate served to both keep riders and operators away from the edge, as well as a ladder for shorter riders to more easily enter the ride unit. The gate had to be manually opened by the operator. The ride had a 450-pound weight limit that was enforced by a scale located near the loading area. This was the weight limit per group, but riders could ride separately as long as they did not individually exceed the limit. The heavier or solo rider would be directed to the left seat. A typical ride cycle would begin with the ride operator taking ride tickets from riders, as the zipline was a pay-per-ride attraction. They would then weigh the riders and allow them to ride only if their combined weight was less than 450 pounds or about 204 kilograms. The operator would then group the riders as needed, with the heavier rider in the left seat. Once grouped, the riders would proceed to the ride vehicle and sit down. Usually, the departing rider from the previous ride cycle would drape the unbuckled seatbelts from their ride over the seat, leaving them unlocked and ready for the next rider. However, this was not always the case, and there was no procedure in place at the park or in the manufacturer's manual regarding clearing the seatbelts at the end of a ride cycle. The riders would sit down and usually drape the seatbelts over their lap, leaving them hanging off the edge of the seat. The operator would then attach the belts to the back of the ride unit and ensure that they were tight. If needed, the locking seatbelt could be unlocked with the ride key. Once both seatbelts were secured and the pin sensor and latch sensor were being flagged on both restraint blocks, the ride key could be returned to the control panel and the gate in front of the ride unit would then unlock. The ride operator would open this gate, and after it reached the fully open position, the ride could be dispatched by pressing the dispatch button on the control panel, which was also located behind the ride unit. The ride would then operate automatically. At the end of a ride cycle, the ride unit would return and the operator would need to manually close the gate. Once this was done, the ride key would eject from the panel and could be used to unlock the restraint blocks, allowing the riders to exit. Interviews with the ride operator working the Soaring Eagle at the time of the accident described the accident cycle being somewhat abnormal, with the involved rider and their riding partner having some confusion over how the ticket system worked. The riders were also not able to ride together due to their combined weight exceeding the 450-pound weight limit of the ride. Accordingly, the group was separated and one rider, who was wearing all black, loaded into the leftmost seat. The operator stated that they buckled the seatbelts as usual while speaking with the other rider who was not actively riding. They then started the ride as normal and everything seemed normal until they heard a scream and noticed that the rider had fallen out of their seat. The investigators reviewed the mechanical condition of the ride and found all mechanical aspects outlined in the owner's manual to be operating properly and to be up to date on inspections and maintenance. This included the restraints, which were found to be properly locking and unlocking, with their sensors properly communicating the status of the pin and the block. Accordingly, the inspectors concluded that the rider must have been sitting on top of the seatbelts when the ride started, as there was no other explanation for why they were ejected. The investigators found after interviewing the involved operator and other operators that usually a rider would hand the restraints to them or drape the restraints over their lap. The operator would then take these restraints and insert them into the restraint receiver behind the rider's seats. There was no standard process for checking if the restraints were actually over a rider's lap, or for ensuring if the restraints were being worn properly. The restraints themselves were dark in color and would not easily contrast with dark colored clothing, making it less obvious when they were being worn improperly. The investigators concluded by reviewing the on-ride photo from the accident cycle, taken a few moments into the ride. In this photo, the tails of the seatbelt can be seen behind the rider and attached to the back of the ride vehicle. However, the location of the rider's seatbelt relative to their lap is not clear in this photo. The investigators looked deeper into the design of the ride and came to a shocking conclusion. All rides should undergo a failure analysis prior to being built. The guidelines for this are set by ASTM standards in the US, and this includes things like looking for possible failure modes, both on the mechanical side and from a human factors perspective. This is not required in all US states, but it is in most, and it's generally considered to be best practice, with every major manufacturer completing one for every ride that they sell. The investigators found that the ride's manual stated, quote, "This document has been completed in accordance with the requirements of the amusement ride industry standards," end quote. No standards were listed specifically, and in further investigation, they came to the conclusion that a failure analysis had not been performed. This was due to the design of the ride and the operating procedures set by the manufacturer completely failing to account for the possibility of a rider sitting on top of a buckled seatbelt. According to the investigators, quote, "The design of the ride relied solely on human input, on the operator to visually detect such a condition, creating a latent unsafe condition," end quote. The manual provided by Soaring Eagle only stated to, quote, "check each of the guest's seatbelt restraints. The ride attendants are required to verify that each and every restraint is locked into position. Failure to do so can result in the passenger being ejected from the cart during the ride," end quote. There was no mention in the manual about the possibility of a rider sitting on top of their seatbelts, or how to look for such a situation, only that the belts must be secured into their receivers. With this information uncovered, we can now reconstruct the accident. On May 29, 2015, Soaring Eagle at Rushmore Cave was operating normally. Two riders approached its entrance and attempted to ride together. Following standard procedures, the riders stepped onto the scale but exceeded the weight limit and were made to ride separately. Rider number 2 waited by the entrance gate and talked to the operator, while rider number 1 sat down in the left seat as instructed. When the operator made their way to rider 1's seat, they saw the belts hanging from the previous ride cycle. Unaware of the rider sitting on top of the belts, the operator secured these belts into the back of the ride vehicle as normal. The operator then inserted the ride key into the panel and went to open the gate. While opening the gate, they could have had a chance to see the rider's lap. However, due to the design of the ride featuring dark-colored seatbelts, it would not have been obvious that they were not being worn. Once the gate was open, the operator dispatched the ride. The rider completed the first half of the ride as normal, but was thrown forwards and out of their seat when the ride hit the air brake. They then fell approximately 15 feet and sustained injuries. The ride was then closed for investigation. The investigation report would be used internally by the park and would be sent to Soaring Eagle. It was not a part of a government investigation and therefore was never released to the public. The report only came to light after a similar incident on the haunted mine drop at Glenwood Caverns. The report was sent to Soaring Eagle in late 2015 or early 2016, with the following recommendations to change the restraint design to one that would make errors which cause this accident less likely. These changes were to make the seatbelts automatically retracting to prevent them from being sat on, revise the mounting place of the ride seatbelt receivers to be closer to the rider's lap to allow for a clear visual indication of when the seatbelt is not being properly worn, or to add brightly colored seatbelt webbing to make it easier to see them in the rider's lap. Stan Checketts and Soaring Eagle received this information and did very little with it. Per ASTM standards, they were required to notify owners of similar rides of this accident with a service bulletin or safety alert, but this was not done. Around the time of this accident report being submitted, Soaring Eagle did appear to implement a software change into their rides that now required the restraints to be cycled between dispatches, meaning that they would have to unlock, have the pins removed and reinserted, then lock again in order for the ride to start a new cycle. It's not clear if this was in response to this accident, as again, there was no service bulletin issued, but it is possible that this was related. With the possible exception of this software change, Soaring Eagle continued to produce rides with the exact same restraint design. These rides would later go on to have very similar accidents. Soaring Eagle would later be dissolved, but their assets and much of their talent would move to Altitude Attractions, who still operates today. In fact, Altitude still sells rides with the exact same restraint design as this ride. As for the park, they would keep the ride closed for the investigation, but would later reopen it with no significant changes, with the possible exception of the software change mentioned earlier. It's also likely that they implemented their own new processes for the operators checking that the seatbelts are being properly worn, but there's no way to know if this is the case. The ride still operates at the park today, and as mentioned, Altitude still sells the ride in essentially the same configuration as how this ride was built. The state of South Dakota would end up mandating compliance with parts of the ASTM standards for ride design and operation at the end of 2015. It's unclear if this accident was related to this though. All in all, this accident was treated by most parties as a one-off. Something that happened once but is not likely to ever happen again. Accordingly, no large changes were made by any stakeholder, and those involved quietly faded away. The accident likely would have been forgotten altogether had the latent design concern been addressed. However, this inaction ultimately allowed the design concern to remain on all Soaring Eagle rides. This resulted in possibly several more zipline ejections, and a fatal ejection on a drop tower at Glenwood Caverns in 2021. While there were several factors at play in the Glenwood Caverns accident, and not all of them were related to the ride's design, it's undeniable that had Soaring Eagle taken this accident as a warning sign, that accident could have been avoided. With the power of hindsight, all accidents can be avoided. Since the Haunted Mine Drop accident, there is finally a greater knowledge of the hazards presented by this restraint design, and many owner-operators are making changes. There are still many rides that operate with this same restraint design today though. Hopefully, in time, this will change. As always, thank you for watching this video. If you are interested in learning more, I have already produced a very detailed video on the Haunted Mine Drop accident if you'd like to see it. Additionally, the accident report used for this video, along with all accident reports I have ever used for videos, are all linked in the description. If you enjoy these factual and non-sensationalized videos about ride safety topics, be sure to like and subscribe so that YouTube continues to push them to more people. As always, thanks for watching, and we'll see you next time.